So we're going to start talking about the actual architecture of software as a service. And for most people these days, software as a service sort of is the web. That wasn't really always the case. But fortunately, we're now sort of developed enough, some of these protocols, that we can kind of take a look from sort of 100,000 feet out. We can take a very big picture view. And for the most part, as SaaS developers, we don't really need to get into some of the nitty-gritty details, but you do need a general understanding of the underlying mechanics of the web's plumbing. So that's what the next few segments are going to be about. The web is a client-server architecture, and that means that it is fundamentally a request-reply architecture. We'll talk more about what that means and what are some examples of architectures that are not client-server or not based on request-reply. The domain name system is a sort of invisible but essential part of the web that maps names of computers to IP addresses, which we'll talk about in a moment. But what that means is that your typical transaction via a web browser is that you will do a host name lookup through your local DNS server. In most cases, it's probably operated by your ISP. That will give a physical IP address of the server or servers you're going to contact. From the outside, that appears to be sort of a single logical entity that we'll think of as a website or a web server. Of course, as we know in reality, these are warehouses full of stuff, but we will come to that architectural decision later. And then you ask it for some content and you get some content back. That's basically, the web in one slide from the highest possible perspective. If we go down a little bit, one level of detail, client server is an example of what we call an architectural design pattern. Design patterns are basically ways of organizing the solution to a related class of problems so that the sort of best practices or best design decisions for that class of problems can be captured and reused over and over again. And in particular, in client server, it just means that the two types of things in that system, clients and servers, are pretty specialized for their task. Typically, the client is making queries or requests on behalf of some human user or some other program, perhaps. The server is waiting for a request to come in. Typically, servers are designed to be able to simultaneously serve many different clients. And client-server protocols are typically request-reply. That means that it is the client that initiates something by making a query. It is the server that responds with a reply to that query. And because they're specialized for their different tasks, it's very appealing to sort of develop software frameworks. So on the client side, a framework like React or iOS, or on the server side, a framework like Rails or Django or Node that essentially captures some of the important kinds of functionality specialized to each type of thing. Once upon a time for the web, the servers used to be pretty complicated and the clients were much simpler. But that was really just because clients were typically people's desktop PCs, then they were laptops, and then they were sort of early smartphones. But as those devices have become lots and lots more powerful, the clients aren't really simpler anymore. They're just complex in very different ways. So the key distinction really is no longer simple versus complex. It's the roles that these things are specialized for. A counterexample of that would be a peer-to-peer system in which basically every entity in a peer-to-peer system acts as both a client and a server. It can both originate things and it can be the receiver of requests. And so the architecture of how you build one is slightly different because you're not really super optimizing for one over the other. Client server is not a new idea. And sort of if we go back in the history of connected networks, there's been a very large number of successful client server protocols. A few of the more well-known ones that you might have heard one. Back as early as 1960, one of the very first client server protocols for software as a service was Sabre. If you have used Travelocity or any of the online travel booking services, you are probably using legacy code from Easy Sabre, which was the original American Airlines developed system for handling their own reservations. It was initially it just worked with them, and it was co-developed by them with IBM. Everything about that server, the client server system, was proprietary. It ran on proprietary hardware, proprietary protocols, a proprietary network, but it was an early example of software as a service. The clients were these specialized terminals that were in travel agencies, and the servers were these big IBM mainframes. There were several installations around the country. In 1971, by the time that universities and scientific labs started to have computers of their own, FTP, the file transfer protocol, was one of the earliest ways that you could say, hey, server, please give me a copy of that file, or hey, server, I would like to upload a copy of a certain file. In 1983, Novell NetWare was an IBM PC product that allowed multiple IBM PCs to share a file server. It was running over proprietary software at that time. And that was shortly followed by the Post Office Protocol, one of the earliest protocols for reading email. Email used to just be a thing that would arrive and a file would get placed in your home directory, and that was your email file. POP allowed it to become a client-server protocol where anytime you wanted from any device, you could sort of connect to the server, grab all of your email, and then disconnect from the server. And that was improved upon a couple of years later by IMAP, which made it possible to have multiple clients. So today, if you are using Gmail or if you're using a mail reader client like Apple Mail on your computer, IMAP is almost certainly the mail protocol you're using. 1990 saw the invention of HTTP, which we'll talk about a lot more. That is the basic communication protocol underlying the web. And that's been revised a couple of times to HTTP versions 2 and 3, which add a lot of performance enhancements that make more sense now than they did in 1990. But fundamentally, the semantics of HTTP haven't changed very much. So even though the version of HTTP that we'll be discussing is closer to the HTTP version 1 family, in terms of how HTTP works, there aren't really significant semantic differences that you need to worry about at this point. Now, of course, right now, we're just looking at these boxes and saying, these are client boxes and this is a server box. As the course goes on, obviously, we're going to look inside the boxes and we're going to tease apart the architecture of how those boxes are designed and implemented. By the way, I would point out that in this slide, all of the protocols that are in solid boxes, these are all open standards. The two that are in open boxes, Sabre and NetWare, represented proprietary standards, but as we'll discuss shortly, even NetWare eventually started moving towards being built on top of more open protocols and open standards.